Hi everyone. Today we're going to learn to sketch the graph of sine and cos in the more basic form, which is y equal n times sine of let's call that AF or something. So we do have two dilation factor, and similarly we're going to do the same for cos. Okay. Um, Now, before we start, let's start with the basic one, which is the amplitude and the period of sine and cos equation. With sine equation, so the more basic form for sine, y equals sine of x. The original form, we start from zero, and then they hit up one, and then they go like that. So one here, and -1 here, as you can see. So the amplitude by definition is the distance between the middle and the maximum. So this we call the amplitude. So amplitude by definition is always the distance, so it's always positive. So in this case, we can see that the amplitude equal 1. All right. If I change instead of 1 and -1, if I change the dilation factor, so if I have, let's do this again. Now, if I insert number 3 in here, then the graph, the line will change from -3 to 3. So in this case, the amplitude will be 3. Okay. What if you add the negative in the middle? -3. So if I do have a reflection, this time I do y equal, um, so I do y equal -3 sine of x, right? So the grind is still -3 to 3, and instead of going that way, the graph will just go upside down because it's reflection in the x-axis. So you can see that the amplitude doesn't change, the amplitude is still 3. So it's always a positive number. Okay, so we write here that the amplitude is the distance between the middle to the maximum of a graph. So because the distance is positive. The periods by definition. So with the basic form, let me do this again. All right. Now, if I have the original graph go like that, this is y equals sine of x. And from where they start here to where they finish, this is 2 pi. Okay, so we call that a period. So a period is the distance between 2 points that when you start and you finish, you finish at the same y value as you can see, and you repeat the same circle. So you have the same pattern every time. So if I had to do another circle, I would go like that. And 2 pi, if I add another 2 pi, that will be 4 pi. And if I keep doing that, if I keep doing another period, it will be like that. So that will be 6 pi and so on. All right. Now, so this is the basic one. If I do have a dilation factors in front of the x, how does that change the period? So here, if I have y equals sine of nx here, all right, then the period will be changed by 2 pi over n. Okay. This is because this is a dilation by a factor of 1 over n from the y-axis. So it's affecting the x value by multiply the period by 1 over n. All right. So to summarize the process, the period is 2 pi on n. So if we just let's call the general equation y equal a times sine or cos of nx. So the amplitude is a number in front of the equation. So the amplitude will be equal a, and the period will be equal 2 pi over n, and n is a number in front of x. Here we do have an example here. So find the amplitude and the period. So we can see the number in front of the equation, that's the amplitude. So I equal 2, period will be 2 pi over n. which is 2 pi over 3. Easy. For this one, as we say, the amplitude is on with the distance, so we don't take the negative into account. Okay, so the amplitude is just 1 over 2. And then the period is 2 pi over n, and our n is a number in front of t, which you can see 1 over 2 is n. So 2 pi over a half, which when you reciprocal that becomes 4 pi. For this one, for cos roughly pretty much the same thing. A equal the number there is 4, and period is 2 pi over n. Now, because t is similar to x, so the coefficient in front of t, that will be n. So we have 3 pi here. So 2 pi over 3 pi, which is 2/3, because pi and pi cancel out. All right. Now, we're going to consider the dilation factors. So as we said earlier, let's say our equations, the original equation is y equals psi of x, right? And we want to transform into y equal a with the amplitude times psi of nx. So what the transformation is take. So the a here is affecting the y value. So you move so whatever, so you can see it's 1 at the moment. So the range here -1 to 1. When you time by a, the range change from -3 to 3. So this affecting the y value. And because affecting the y value is dilated by a from the x. So it dilates from the opposite axis. So dilated by a factor of a from the x-axis. Okay. And now if we consider, the x here, so we have x, and now that changed to nx. So as we said earlier, when you multiply n in front of the x, the dilation, you actually string it, make it actually smaller. So dilated by 1 over n from the y-axis because affecting the x value. All right. We do have an example here. So this is our original equation, and this is our image equation. So they want to stay given a C1 transformation. So the J, what we say that is dilated by a factor of J. Here I don't have enough rooms. Dilate factor of J from the x-axis. Okay. And then the 2, this will be, so with the 2, you always flip it over. So you say dilate by a factor of 1 over 2 from the y-axis, right? And similarly, you can do for B, pretty much the same thing. Now, for the example here, sometimes they might ask you backwards. They might give you the original equation and they give you a list of transformation here. Dilation by a half from the x and then followed by dilation of 2 from the y. So in this case, what we're going to do, so we have y equals psi of x. Yeah. Now dilation by a half from the x. So as we say, if it divided by I from the x, there's the coefficient in front. So we would insert a half in front of our equation psi of x. So we have a half here. Then followed by dilation factor of 2 from the y-axis. So if you can see, if it from the y-axis, you're going to insert the number here. But remember, these numbers are supposed to be reciprocal, so you're supposed to be flip them over. So if at n here, you write 1 over n. So oppositely, if that 2 here, I'm going to write, I flip it over, this will become 1 over 2 in the equation. So the letter x here, I'm going to replace letter x as 1 over 2 and then x, okay? And everything here I write again. So y equal a half psi of a half of x. All right. Now we're going to learn sketching sine cos graph in the more basic form, which is y equal a times sine of nx, or y equal a times cos of nx. For the translation vertically or horizontally, we learn next lesson if you watch out for that video. All right, so how you sketch it? Your first step is you find the amplitude first. And as we say, the amplitude is just the number in front of sine and cos. So which is I, but remember it's always positive. Okay. Um, Here we have an, all right. So amplitude equal A. Now the range will be negative A to A, as you know. Now next step is you find the period. So the period is 2 pi over n. Okay, right, 2 pi over n. Now to make it easier to sketch, we're going to do another step, and I usually call that a step, how much is each step or how much is an interval. So what does that actually mean? If you think about the sine graph, so you know the sine graph that go like that would be y equals sine. So you can see that the original sine graph, let's say this is the original y equals sine, that's the more basic one. So the period is 2 pi. Now, for the one period, they actually break up into 4 different smaller quarter. So as you can see, I want to know how much that is here. Okay, so you can see because that's 2 pi, this will be half of pi, half of 2 pi, which is 1 pi, and this is half of pi, and this is 3 pi over 2. So this is easy because you can easily identify. But if I insert the nx in, so I here, so I do have the amplitude, the range negative a to a. Now, because I insert the n, the period will be 2 pi over n. Okay, so I want to know how much is one step here so that I can figure out the point on the x-axis. That's what we call a step. How much is the gap between each point on the x-axis. And you can see one period is divided into 1, 2, 3, 4, 4 quarters. So the step is always a quarter times a period, and the period is 2 pi over n. And then once we do that step, we're going to get, sorry, we have the point, and then we can just do all the point when fit the domain in. So our last step is get the point. So the point, we start from 0, and then for each point, we're going to add each step as we go. Okay, so they have an equal gap. Okay, and before we go with the example, let's just remember that sine graph. So you have the minimum here, the maximum, and the middle. So I should do that. Maybe because this doesn't have a translation, let's make a middle is 0. So 0 is the middle here in this case. So sine graph, we start middle, maximum, middle, minimum, and back to the middle. This will give you a period. So this is positive side. Okay. If you have a negative side, it just upside down. So start from middle, minimum, middle, maximum, and back to the middle. This will be negative side graph. If you start for cos, you will have maximum, middle, minimum, middle, and maximum. So cos will go like that. And of course, negative cos is just upside down. So minimum, middle, maximum, middle, minimum. So you have like that. Okay. So, but the steps are pretty much the same. It just depends on where you're starting of the type graph. All right. Now let's do this one. Here I have the domain and my equation here. So we're going to follow this step, right? So our first step is we find the amplitude, which is the number in front of sine is 3. Yep. Range. So the amplitude for 3, so the range will be -3 to 3. Period. So the formula for the period is 2 pi over n, which is n is a number in front of t, which is pi. 2 pi on pi is 2. Now, so the period equal to, so a step of is a quarter of the period. So we do 1/4 times the period. As you can see here, 1/4 times the period. There will be 1/4 times 2, which is 1/2. 2/4 is a half. So this means the point that you're going to have on the x-axis, you start with 0, right? And then every time you're going to go by a half. So 0, 1/2, and then 1/2 plus 1/2 is 1. 1 plus 1/2 is 1.5. And then you have 2. So doing this method, it gives you all the points on the x-axis easily. But if you're comfortable finding straight away, you don't have to do this step. All right, so let's put them together. So I look at the range is -3 to 3. And I have all the point here. I have 0, I have 1/2, I have 1, I have 1 and 1/2. Let's make it 3 to 2. And then I have 4. I have 2, sorry. So, and then I look at my graph. So this is a sine graph, right? So as you know, sine graph start from the middle and go like that. So I start from the middle, which is 0. Next point hit the maximum. Next point hit the middle. Next point hit the minimum, and then back to the middle. So you have a period, which is exactly what the domain want you as well. If the domain is different, then you need to expand it or cut out some part. Okay, so check that. All right, we're going to do two last example here, which a negative. So pretty much the same thing. We follow the same step. Let's say I'm going to do, okay, so the amplitude equal to not negative, because negative just reflection. The range is still -2 to 2, okay? The period is 2 pi over n, and in this case, n is 1/2. So 2 pi over 1/2, which is 4 pi. So the step, which is a quarter times a period, a quarter times a period, which is a quarter times 4 pi, is 1 pi. 4 and 4 cancel out. So you know the point you're going to have is points. So we have, what do we have? We have 0, and then we go by pi each time. So 1 pi, 2 pi, 3 pi, 4 pi. Now we have everything together. We can put them on the graph. So the range is -2 to 2. And we have all the point here. So we have 0, 1 pi, 2 pi, 3 pi, and 4 pi. Okay. Now, because it's negative, it's go upside down. So negative side, we go like that. So we have start from 0, and we go to the minimum, middle, maximum, middle. So we have a graph that looks like that. Okay, and exactly what's the domain one as well. All right, we're going to do question B, but this time we're going to do for cos graph. So let me just delete this and we start the same process again. Okay, and this technique works for any type of sine cos equation. All right, now amplitude. All right, let's talk about it. So we do B. So the amplitude equal 1, because the number in front here 1, and the distance is amplitude, so not -1, just 1. The range is -1 to 1. The period is 2 pi over n, and n is 2, which is pi. A quarter of a period is 1/4 times a period, time a period. So 1/4 times pi is pi/4. So the point you have, you start with 0, and then you go by pi/4 each time. So 0, pi/4, pi/4 plus pi/4 is 2 pi/4, and then 3 pi/4, 4 pi/4, which is 1 pi. Here my domain is 0 to 4 pi, so I do need to keep going, but I'm going to sketch the period first, and I can do that on the graph probably faster. Now, okay, so we have -1 to 1, and then you add in. So you have 0, you have pi/4, 2 pi/4. We simplify that later, okay? 3 pi/4, 4 pi/4. I haven't simplified yet because I want you to see the pattern. And then I need to go to 4 pi, don't I? So this is just 1 pi, so I keep going. 5 pi/4, 6 pi/4, 7 pi/4, and then I have to go all the way to how much? 4 pi. 4 times 4 is 16, so I have to go all the way to 16 pi/4, which is quite long. Okay, I'm not going to do that here, but you get the point. Now, negative cos graph. So negative cos start from the minimum. Go here, go here, go here, go here. So you can see one period here is 1 pi, right? So on your graph paper, so one period is 1 pi. So if you keep going to 4 pi, you're going to have 4 periods. So you will have here, 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 and here. So by the time that you reach the next one, you're going to have 2 pi, and then you have 3 pi and 4 pi as the last point.